Hi, I'm Dr. Tom Gerard, and I am going to go over some things for your final project. Now, I know some of you have been submitting your projects, and I've been responding. If you see that you've got score, you'll get full points if it's an acceptable project. If you've submitted something and I've made some comments and you didn't get any score, then you need to revise it or clarify it, something like that. But once you do, you'll get full. Once you correct it and we say that it's a good project, then you'll get full points. But right now I want to go ahead and go through some things. So your project is really based upon chapters 10 and 11. Chapter 10, because it goes through the 6 steps. Your project will ask you for the 6 steps. You will enter that right into MyRSU. You will have to gather some data, calculate the data in Excel, and then take the data from Excel and put it into MyRSU. You'll upload your Excel sheet that you have your data, but you'll have to fill out the project questionnaire in MyRSU. Now, if you follow along what I'm going to go through right now in Chapter 11, and if you have your book Chapter 11 or download the PowerPoint that's made and the spreadsheet, I have this right up there in your course resources. So let's talk about this. So first of all, Chapter 10 goes through the 6 steps. Now don't get confused by 6 steps. There's actually more than 6. This book squishes them down into 6. Some books have 10 steps, some of them have 7, some of them have 5, but they're all the same steps regardless of what statistics book you're using. This book just happens to call them 6 steps, and they've got multiple steps in each in some of the steps. So you're going to have to go through them all. So let's do this. You have 2 samples. You have 2 samples, and you're testing the differences between these samples. Okay, that's what we're talking about here. And you're going to have to gather the sample data. So let me move my deal here, and let's take a look. Well, now first of all, this chapter starts off talking about 2 population means. You're really comparing 2 sample means. Is there a difference in the mean value of residential real estate sold by male agents and female agents? These are good questions to give you an idea what you should be studying. Not necessarily you have to study real estate or male and female, but the way this is laid out, you have 2 groups, males and females, and you have 1 variable, the value of real estate. So that's what you need to focus on. Don't try to put in more variables than you need. 2 groups, 1 variable. Okay. Is there an increase in the production rate after music is piped into the production area? Okay. The groups are before and after the music is piped in. So the production rate is the variable. The 2 groups would be considered before the production rate, before the music and after the music. Okay. Now, you'll notice that when you start off this chapter 11, it starts talking about z-scores. But the thing that you use z-score, it says right here, the population standard deviations are known. Well, we're not studying populations, we're studying 2 samples. So this doesn't apply to us. We need to go to t-test. Okay, so we're going to use comparing 2 means using the t-test. T-test for 2 samples. There are 3 different, well, the main thing is you don't know, you have unknown standard deviation and variance of the population, right? You have to, and so you have to pull the sample standard deviations of the different samples, right? To come up with what you're going to estimate. And the t distribution instead of the z. I don't want to go into all of this because it's really not necessary. This is what you're going to use, 2 sample t-test. Now, the question is the sample dependent or independent? And that's one of them that we'll look at here in a moment. But let's take a look at. First of all, every test that we run has the same requirements, basically. Is it normally distributed? Well, we're assuming that everything is normally distributed. That's why we talk so much about the normal curve, because whatever it is that we're studying, we're assuming it's a normal distribution. And that's true for the t-test, the z-test, the the F test, which you'll experience in Chapter 12. The sample populations are independent. Now, this is independent. We'll look at dependent ones also, but for now we're talking about independent. We'll get into more what that means. Okay, standard deviations of the two populations are equal. This is an assumption. Now, when I say equal, I don't mean that they're both exactly 4.3 or exactly 5. You could have one that's 5 and one that's 6, and one that's 4 and one that's 7 even. It's not that they're exactly the same. You're assuming that the variances in your population or your samples are relatively equal. Okay, and again, I don't need to get into all of that here because I'm trying to just use the time to focus on to try to focus on what it is that you need to know for this project. All right. Now, whenever you start looking at this, you're going to see a lot of formulas. The pooled variance you're going to need to know. You're going to have to calculate the t-test. You're going to have to find what the critical value is. You're going to have to find out what the p-value is. And those are all big questions. Some of these formulas look confusing, but really what we're interested in, if you'll see here in the numerator of the t, is this sample different, negative, difference? What is the difference between these two? Is there a statistically significant difference? That's what we're asking, right? So don't let these get you confused. I'm going to show you how to do all this in Excel in instantaneous to make it easy on you. Here's the formula for the t. It's going to be easy. Okay, so let's take a look at a sample. I think, is this the sample I want to do? Sure. This is right out of your book. Owens Lawn Care manufactures and assembles lawnmowers that are shipped to dealers throughout the United States and Canada. 2 different procedures have been proposed for mounting the engine. The Wells method and the Atkins method. The question is there a difference? Is there a difference in the mean mounting times? This is your hypothesis. What is your hypothesis? So here's your steps. This is what you're going to have to do. State the null and alternative hypothesis. Now, this is what we call state the null and alternative hypothesis in symbols, which is this mean is equal to that mean. This mean is not equal to that mean. So we have the null hypothesis and the alternative hypothesis. Typically, especially if you think one is greater than or less than, that's what you think your hypothesis is. This football team's better than that football team. This group of people scored better on something than that group of people, right? Then you're going to always want to start with, when you're thinking about it in your mind, you start with the alternative hypothesis. Okay, what do I think? Well, I think that, Dallas Cowboys is better than the Patriots, whatever. So that's your alternative hypothesis. Then the null hypothesis, there's no difference. Now, if I said this is equal and not equal, this would just say there's a difference in the 2 teams. Okay, but you start with your hypothesis, and that's going to set the way that you choose all of these different things going forward. So next thing they're going to say is the significance level. What is the significance level you decide? Well, in this case, they've chose 0.10. We probably won't be using this. In fact, this is rarely used. It's almost always 0.05 or 0.01. So think about in Chapter 9 when we talked about the confidence level. That was 95%, 2 standard deviations from the mean. 95% means the significant level of 0.01. I'm 95% confident that I've made the right decision. Determine the test statistic. T, we're going to use the independent. Now this is called the sample pool test example, but we're going to use an independent to sample T. Independent meaning they're not the same. A dependent test, which they show later in this chapter, is normally when we're going to introduce some kind of treatment, or some kind of process to change things. So in other words, we're going to, like the one that we had with the music. Did something change because we introduced music? Is a person that's sick going to get better if we give them this drug? So it's the same person or the same group of people in the sample, but there's been an intervention. That's called dependent, because it's the same people that's being tested both before and after the treatment. Or in the case of the factory, the production in the factory is the same factory, the same workers. The only difference is that they've introduced this, the music. Now here, under independent, we're talking about these two different methods. They're not saying that these people, had some kind of intervention. It's two separate things that we're studying. Okay. So determine the test statistics. The fourth thing is formulate the decision rule. Okay. So now this looks like chapter 9 again, where we have this confidence level. So this confidence level is made up by this critical value. There's a critical value on either side. Now, why is it on either side as opposed to one side? Well, it's because this is what we call a two-tailed test. So on your project, you're going to have to answer. One of the questions is it a one-tailed test or a two-tailed test? In this case, because it's equals, it's a two-tailed test. So if I said there's a difference between the Dallas Cowboys and the Patriots, then in the 2019 season, then you could say there's a difference, which means they could be better or they could be worse. Okay, now they could fall over here in this rejection region, or they could fall over here in this rejection region. If they fall in here, then there's no difference. Okay, so this is two-tailed. What would be a one-tailed? A one-tailed would be saying, I think the Patriots are better than the Dallas Cowboys, right? Or I think that the Dallas Cowboys are scored less over the season points than the Patriots, or whoever you choose, right? I'm just using that as an example. So if I use a less than or greater than in my alternative hypothesis, it's a one-tailed test. If it's a not equals in my alternative hypothesis, it is a two-tailed test. The null hypothesis will always have an equal in it. So it could be here where it's just equals, or it could be greater than or equals, which is, your little greater than sign with the equal underneath, or the less than, okay? So that's the one-tailed or two-tailed. It makes a difference because this critical value is going to be different depending on what you choose. Okay, now we've chose in this example 0.1. That means 90% confidence as opposed to 95. For you, I recommend 95. Okay, now we're going to look at a bunch of math. Make the decision regarding the null hypothesis. It takes 3 steps. First, calculate the standard deviations. Well, you're going to calculate the mean and standard deviation of all of these and the n. How many is in each group? Now, look at this. This looks nasty, right? But don't worry about it. I'm going to show you how to do all this very simple. Okay. So here's the pooled sample variances. We have to calculate that. And we have to, that's going to be one of the questions. What's the pooled sample variances? Okay, now I could go through all this formula. It's really not as bad as it looks, but for this video, I'm really going to focus on how do I make Excel do this for me so I don't have to worry about all this math. Third, determine the value of t. Okay, so I've got a few steps. Make the decision regarding the null hypothesis. What is the decision? The decision is if my statistical value, the t value, falls within the rejection region, I fail to reject the null. If it falls if it falls in the do not reject, I do not reject the null. If it falls in the rejection region, I reject the null. Okay, that's the decision. And then of course the step number 6 is interpret that. Okay, so we're going to do that. Here we go. Number 4, number 5. I've done all this math. Let the computer do it. I'm going to show you how to do that easy. Here's the Excel output. And if you'll notice here, here's my raw scores. This is what you got to come up with. You're going to have raw scores. You have to have a sample. Okay, so if this is the scores of the Patriots and this is the scores of the Dallas, you can't just have, on one game, okay, on this one game they scored this, or in the Super Bowl this is what it was. It has to be the whole season. You need all of the scores, because that way you calculate the mean and standard deviation. So you have to have a sample. If you're doing a questionnaire, do the girls like vanilla ice cream more than boys? Well, how you gonna, is that yes or no, right? Well, we can't have yes or no because I can't calculate a mean on yes. So I need questions on a scale from 1 to 10. I think vanilla. When I think of ice cream, I always think of vanilla. When I want to have ice cream, I like vanilla on a scale from 1 to 10. And so you're going to give the same survey of at least 3 questions. You have to have at least 3 questions because you need to be able to count the mean and standard deviation. Remember, the standard deviation and variance really means the same thing. It's how spread out are the numbers. If I have one number, there's no spread. Okay, so we cannot calculate it without a spread. And to get the spread, we have to have a minimum of 3 numbers. Now, if I have 20 people that I'm surveying, I'm going to ask all 20 people the 3 questions, right? So each person has a mean and standard deviation. Okay, that's the sampling, chapter 8. Okay, so here we go. Here's the mean, here's the variance, the number of observations. Is it okay that they're different? Yes. You can have, in this case, you have 5 in one and 6 in the other. You could have 8 and 10. You could have 12 and 15. Now, if you have 2 and you have 100, I'm exaggerating, obviously, to make a point, then your statistics are going to be no good. Okay, they need to be relatively close, but they don't have to be exact. Pooled variance, there's the number that's calculated with that big, one of the big formulas. And then here's the T statistics, negative 0.0166. That is the test statistic. Now, we've got to figure out what's our critical value. Okay, so what determines the critical value? Is it a one-tail test or a two-tail? So T critical 1, T critical 2. Well, this was a two-tailed test on this example because why? We were using the equal sign on the alternative, and null hypothesis was equal and not equal. So the critical value is 1.833. That's given to me by the software. And if we remember, that's what it was right here, 1.833. It's not always 1.833. It's a calculated number. Now, your book will go, and most of your statistics books will go into a lot of detail about how you look this up in the chart in the back of the book. That's wonderful if you want to do that. But if you use Excel, it's going to provide it for you. So what you're going to have is your 2 groups, boys and girls, Republicans and Democrats, third graders and fourth graders, the Dallas Cowboys in 2019 and Dallas Cowboys in 2018, the Dallas Cowboys and the Patriots. Always 2 groups and multiple numbers. Okay, so you're going to put this into Excel, and it's going to throw all this stuff out here, and you're going to be able to answer the 6 questions. Okay, now so 6 questions, but some of them have multiple questions. So here's the thing. The decision is to not reject the null hypothesis because minus 0.66 falls in the region between 1.833 negative and and positive 1.833. So back to our drawing. Always think about the drawing in your head because that helps you understand. This is the rejection region, and because that 1.66 is within here in the do not reject, and what does that mean? What does that mean? We conclude the sample data failed to show a difference between the mean assembly times of the two methods. So we failed to reject the null. If you fail to reject the null, then and you failed because it fell in the do not reject region, if that's what you come up with, then you conclude there's really no difference. Okay? So if this was your data, there's no difference between the Cowboys and the Patriots. There's no difference between the boys and the girls. There's no difference between the freshman and the sophomore, or the upperclassmen and lowerclassmen. There's no difference between the Democrats and Republicans. So those are just, of course, I'm saying that as just examples. We know there's difference between all these groups, but whatever it is that you're studying, there's no difference, right? In this case, it's the method of installing the engine. Okay, let's do this real quick. Let me see if I can pull my Excel up. I'm going to show you. Oh, there's our numbers. I put them in Excel. Pretend like this was your numbers. Okay? Whatever you're going to be studying, you're going to put in the two groups, the numbers. And now here's what we're going to do. On my Excel, up at the top, I've got the Data tab. I want to click on the Data tab. On the Data tab, let me make sure I got it right there. I've got way over here on the right, the Data Analysis. If you do not have the Data tab in the Data Analysis, go back to week 1 video on where I show you. I will show you, there's a video I have on, you choose a little drop down and you choose week 1 or unit 1, and the video will be in there on how to install that on your Excel. It's no charge, it's part of the system. All you have to do is just do a little process to get it show up. So now we got it there, and so here's what I'm going to do. I'm going to go in and I'm going to hit that. Whoops, let me go ahead and do this so you can see what I'm doing here. So there's the Data tab, there's Data Analysis. I'm going to click on it. And it brings up this box. And what am I trying to do? Here's a bunch of statistical things. I'm going to scroll down because I'm doing what? I'm doing the t-test paired 2 samples for means, right? And that's the one we're doing, okay? 2 samples for means, paired, wait, I'm sorry. 2 sample t-test, assuming equal variances. It's not paired because they're not dependent. This is independent. So we're going to get 2 sample assuming equal variances. If you were doing the dependent, where it's the 2 group, where, you know, like I said, you would choose that one. But we're going to choose this one because they're independent. Okay. Now it's going to ask me where my variable input is. Let's see if I can get this over here. We can see it. Okay, so here's my my data. I'm going to choose the heading as well. First of all, let me click in there. I'm going to choose that. I'm going to put that. Choose that. Now, hypothesis mean difference. What was that? What is the null hypothesis? 0. 0. There's no difference. I'm hypothesizing for the null that there's no difference. So always put 0 there. Labels, yes, because I chose the label. Alpha. Now this automatically here is showing 0.05, which is what you want to use. But because I'm trying to do the one in the book, I'm going to put 0.1. Right? That's what they did. Now output range, I'm going to choose to put it right here. Oop, where'd it go? Output range, I'm just going to put K5 so you can see it right there. K5. And there it is. Okay. And what am I looking for here? There's the means, variances. Now, again, you can see, is there a difference between 4 and 5? Not really, right? Okay, we can see that. But how do we know that there's no statistical difference? What you're going to be asked. Mean, variance, the N observations, pooled variance. That number is going to be asked. Here's your T statistic, right? And then what are we doing? 2-tailed test, T critical, T two-tail, 1.83. And your question is, does this exceed that? Now, this is plus or minus, right? Because it's on either side. It's a two-tailed test. So is it less than negative 1.83, or is it greater than 1.83? And as you can see, it's negative, but yet it's not less negative, below negative 1.83. So our decision is it falls within the fail to reject region, so we fail to reject the null hypothesis, and we're going to conclude that there is no difference between these two methods of installing the engine. Okay, I hope that's helped you. Remember, use the Excel. It's going to be easy. Again, let me just do this. I want to show you. Go, boom. I'm going to do it again. I know I want to get rid of that. Just to show you that how easy this is. Now, even if I had a whole bunch of numbers, this could be 100 numbers. It doesn't matter, but you got two groups. Let's do it again. Data, I know you can't see the data. I'm going to data analysis. Here's my little questionnaire. To sample, assuming equal variances. Okay, there's my input range. And I put that in there, highlight it, stick it in there. Here's that one. Hypothesis 0, labels yes, alpha 0.01 for this example. You use 0.05. Output range right there. Boom, okay, done. Okay, now it's going to give me the numbers, or you can go do all those formulas by hand if you like. You can even do all those formulas in Excel. Now, on the spreadsheet that's in Chapter 11, down at the bottom, you'll see I have, let me get rid of this, independent, and I have dependent. So here's the one that says paired. So if you did this one, which is also in your book, as an example, they're looking, and here's the thing from the book. They're trying to determine whether or not the house is appraised at a different value by two different appraisers. But the thing that makes them paired or the same is it's the same house, right? So this is the same house appraised by two different people. Do the same thing, come up with the mean. Critical two-tailed, because it's just saying is there a difference? And here's the statistic. Now in this case, take a look. T statistic 3.3, the two-tailed critical value is 2.26. So what does this mean? This is in the rejection region. It's beyond. I like to say beyond, because if it's two-tailed, it could be less than or it could be greater than. But in this case, it's 3.3 and this is 2.6. So now we conclude that we have concluded that we can reject the null hypothesis, and our conclusion is that there is a difference between the two firms that do the house appraising. Okay, I hope this helps. I know this is really fast, and I know it's not fast because it's 30 minutes, but I didn't really go into a whole lot of detail here because I really just want to get you to so you can relax a little bit and not have to worry so much about mathematical formulas and all those kinds of things. It's more about that you're going to be able to learn the process. The steps are the same. No matter whether you have 10 steps or 6 steps, they're the same for every class that you might take in statistics, for every science. So it doesn't matter whether you're studying moon rocks or geology or the weather or astrophysics or science, medicine, it's the same. Okay, thank you. If you have any questions, please feel free to email me or respond in the forums. Thank you.